Hi everyone, my name is Huang Long Chen, and today I will be explaining the analysis I have done on the COVID-19 YouTube videos. I have collected from 13 different news channel or outlet on the topic of COVID-19 from December of 2019 to March of 2024. Here's a quick overview of the entire data science task. The data cleaning and preparation process have been done for me by Dickon, but I will still go through it. And the analyzing part is where I will go in depth. I choose question E1.1, E1.3, and E2.3. I have chosen these specific questions because they are connected in my observations. And the main thing about the observation is that it's a lot about the comments on the YouTube videos. I'll be doing some different analysis on the comments and also a bit on the views and likes as well. And yeah, let's get started. I'll talk about the collecting the data. So you can have this notebook that collects data for you automatically if you run through it. You just need to put your credential here, the YouTube credential that there, and if you run this file, it will automatically install the libraries you won't have. This part right here is important to understand because you need to put the start date and end date of when you want to script, and the keywords is the keywords to for it to search on YouTube. So I do about COVID-19, so I just leave it as the default, but you can do about other news like Andrew Tate or AI. But I feel like COVID-19 is the most appropriate because it gives a lot of information and it's easier to analyze. I feel like it. And this channel is a dictionary. I I have add more channels. I have add more channels for it total of 13. I did by using this function, and this again was section H, which is a credential loading the YouTube credential. It is for this parameter, right? This parameter or argument right here, and you need to put your video ID here, and it will return the channel ID and the channel title, which is this to return the channel ID and channel title. And for the most part, you don't really need to understand anything else because you just need to understand a few function, and it will scrape it for you, scrape the Excel file, the comment and the videos that you'll be using for analyzing. And yeah, and the cleaning part, they can also provide a code to clean everything. You don't need really to care, you only need to care about these two um, data frame. And yeah, that's about it. So now the most important part, the analyzing part. So first I will look at the distribution of the views, likes, and comment for the 13 channels. So first I look at the columns to see the most important features to use, and I choose these three features, and I print out. I use the function describe some measurements, describe the mean, the median, the not the median, the mean, the standard deviation, and all of that. And I plot a subplot with one rows and three columns for the tree distribution, and I use a for loop to loop through I loop through and print out each distribution, which I print out the KDE, the kernel density plot, to be true to display the kernel density plot, and it's measured in what is this 10 million, and it's really hard to interpret. I can see that it's right skewed, the distribution is right skewed, and I can confirm that by printing out the skewness, but it's hard to interpret. For that I need to box a box plot for each of the feature. So first of all, I just bought the box plot, oriented this, make it horizontal, and calculate the lower and upper bound using interquartile. So I see that the upper bound for view is 10 million and the lower bound is 0. And I see some very extreme outlier. I wonder why the extreme outlier exists. And I need to find the videos of the extreme outlier. And when I try to find I drop the duplicate here. I try to find the max view. So drop some duplicate and plot it, and I see the video, the most extreme outlier in the view count, and most of it are in 2020. Interesting, in 2020. Now I did the same for the like count and the comment count, and find the extreme outlier of the distribution. Why the outlier extreme in those distributions? And so after some research, I know that COVID-19 was declared during Zosam during March of 2020. So people are interested to looking, viewing, commenting, and liking the videos at that time because they want to be informed during time of uncertainties. And I I can I want to even look at the correlation, but I think it's for another time. The causation and correlation for another time. But now I'm moving on to the next question. I look at the user feature first and group the data by months, by publish and comment count. So the total comment count per month, not per week, because per week is really hard to look at. But if you do it per month, then it'll be easier to interpret. So now I will talk about this per month. So I create a subplot, but it's just for one plot. Create subplot, it just make easier to code. And I set some major events, dictionary, key, and item. I loop through the item, and I denote like the red triangle for the events. And if the event don't exist at that time, then it will just print out it doesn't exist. And I display the plot. And if you can look at this, from the last question, remember, most of the most extreme videos of number of likes, comments are in 2020, especially from March, from February to like April, especially in March, where people are very scared. So that's why they're commenting and viewing the videos. So as you can see, after the declaration of the outbreak to the global pandemic, the number of comments skyrocketed from like 500,000 to 8 million total a month. That's crazy. But afterwards, you see a declination, and now no one really care about COVID anymore. So that is very interesting. So the next question I'll talk about, like, I would very similar to question 2, but now I will plot the line plot, the old time series plot for each channel, or for selected channel. Like, I need to select the popular channel because it show more information. Then I just plot all channels. And first, so just explain this part. So I will display the necessary columns. I display the necessary column, and I see some duplicate in the comment count, so I drop those duplicate, and here I drop some duplicate here, dropping duplicate, and then a group channel title and months of published by the total comments. So here, so here's a table. So very similar. So the total comments per that month, and if we plot it, so I use a pivot table to plot the time series line. So very similar to last question, you can see that CNN has like 90,000 comments per that month. Very crazy. And from January to June, where people are very uncertain, is the uncertainty time, so people interested and comments for the videos. But after that, you see a declination, and the question asked me to remove the outlier, and I remove the outlier using interquartiles. So I loop through each channel, unique channel, and I look for the upper limit and lower limit of that channel and remove those. So I filter out those information, so extreme outlier. But the thing is, if you, so this plot doesn't have outlier, have outlier, and this plot, well, it removes most of the outlier. But if you take a look at the plot, you see even in this plot, the line up disconnected already because omitted value. omitted value, just value doesn't exist at that time, it's lost. And when you remove outlier in in time theory plot, you cannot really interpret anything, because these outliers are from the natural variations. It happened naturally because channel want to update the news about COVID-19 at that time or at any time. And if we remove that, then it wouldn't follow any natural variation, and you cannot. So now I will talk about like some of the challenges I faced when analyzing and how I overcame it. So the first thing that is hard is understanding the problem. I need to understand like how to collect the data. So I have to understand like what is API, how to use API, how to use YouTube API, how to use the credential, how to use the function by Deacon to script the YouTube videos. And after that is the analyzing part. So it was brutal. I need to analyze. I analyzed everything. Like what I mean everything, I mean I analyze every question to also to fill in my knowledge gap and to choose what question is the best to present. And and the knowledge gap here, I mean like statistics, is mostly statistics, and I need to learn about the distribution, the skewness, box plot, outliers, correlation, Spearman, Pearson, all that stuff. And I overcame it by just researching and learn about the different libraries. And I think that is all.